When two nutritional compounds activate the same cellular outcome through completely independent molecular mechanisms, the convergence is worth examining carefully. Vitamins A and D are both fat-soluble, both act as nuclear receptor ligands that regulate gene transcription, and both independently induce autophagy in immune cells, but through different receptors, different gene targets, and with somewhat different tissue specificities. The practical significance of this dual pathway activation is that combined adequacy of both vitamins produces immune autophagy induction more robustly than either alone, and combined deficiency, which is far more common than deficiency in either vitamin in isolation, particularly in populations with limited diverse food access, impairs infection defense more severely than single deficiency would predict. Retinoic acid from vitamin A binds retinoic acid receptors and upregulates Beclin-1 and LC3 in macrophages and T cells. Calcitriol from vitamin D binds VDR and upregulates ATG5 and ATG16L1 in the same cell types. Together, these two transcriptional programs activate both the initiation and the elongation phases of autophagosome formation simultaneously, the biological equivalent of pressing both accelerator pedals rather than alternating between them. The downstream result is macrophages with enhanced capacity to capture intracellular pathogens, more efficient T-cell regulation of inflammatory intensity, and better tissue homeostasis in epithelial barriers where infection entry first occurs. The infection-specific application of this synergy is supported by clinical evidence from research on respiratory infections. Vitamin D deficiency is associated with increased rates of upper and lower respiratory tract infections across multiple epidemiological studies. Vitamin A deficiency is associated with increased measles severity and respiratory epithelial susceptibility. The combination of both deficiencies produces substantially more severe infectious vulnerability than either alone, consistent with the dual pathway immune autophagy model. A specific warning about therapeutic vitamin A dosing during infection requires clear communication. Short-term high-dose vitamin A in the range of 10,000 to 25,000 IU for adults during acute infection has been studied in clinical contexts for respiratory and measles infections, and there is evidence supporting this use in specific populations and clinical settings. However, this dosing is therapeutic and time-limited, not a chronic supplementation protocol. Chronic consumption of preformed vitamin A above the upper tolerable intake of 10,000 IU daily accumulates in liver and adipose tissue with documented toxicity consequences, including bone mineral loss, liver enzyme elevation, and in pregnancy, the teratogenic effects discussed in other contexts. The distinction between acute therapeutic use under medical guidance and chronic supplementation is not a fine point. It is a safety boundary that determines whether vitamin A supplementation is beneficial or harmful. Meal planning that addresses both vitamins simultaneously is more straightforward than sequential optimization. Fatty fish, salmon, mackerel, sardines provide substantial vitamin D alongside omega-3s. Eggs provide moderate amounts of both vitamins. Liver provides exceptional concentrations of preformed vitamin A alongside meaningful B vitamins and iron. Pairing these with orange and yellow vegetables that provide provitamin A carotenoids creates a comprehensive approach across one day's eating that leaves neither vitamin undersupplied in people who can convert carotenoids adequately.